Hello guys, I'm gonna talk about mesh analysis, what it is and how we can apply it in a circuit. So mesh analysis is basically using KVL rule in each mesh in our circuit and finding an equation for it, and then at the end we're gonna have a couple of equation and finding our mostly we want to find the currents inside the circuit, or we find the currents to find some voltage or something else in our circuit. So here I'm gonna show you step by step how do we apply it in a circuit. I don't have any numbers here to not make stuff complex, but I just want to show you how it's happening, how we're gonna apply this analysis. First things we do is that we're gonna look at our circuit and see, okay, how many meshes do we have? Here we have 1 and 2, and we're gonna define a different current for each mesh. For example, here, and a direction for that current. For example, here I say this is my I1 coming in this direction, and this is my I2 coming in that direction. We have, as you can see here, there is a different current here. It's not same as I1 or I2, because as you can see, I1 is going into it, I2 is coming out of it, so it's completely a different current. So what do? I just put a direction here and I call this one I3. But first things first, I want to show you something before we start the mesh analysis. If we say we have a node A, if you haven't watched my video on nodal analysis, I advise you to watch it before this one, because I'm gonna use nodal analysis for these currents in here. So I say at node A, we said that the currents going through one node are equal to the currents coming out of one node. Here, I2 and I3 are coming out of this node A, and I1 is going through it. So I2 plus I3 is equal to I1. So if we want to find I3 alone, I3 would be I1 minus I2 if it's in this direction. For example, if we're going through this loop, it's in this direction, so it's I1 minus I2. But if we are in the second mesh and we're going through the mesh like this in the direction of I2, when we get here, this is in the opposite direction of where we're going. So it's gonna be minus I3, it's gonna be minus I1 plus I2. I'm gonna show you in a while. So first things first, I said in mesh analysis, we're gonna define one current and its direction for each mesh, which we did here. Then we're gonna go through those meshes one by one. So here I say mesh 1, and I'm gonna apply KVL rule for mesh 1. What was KVL rule? KVL rule, I have a video about it, you can go and watch it, and here I'm gonna explain it shortly. That KVL rule, Kirchhoff voltage law, says that in one mesh, if we go through one point and we come back to that one point in one direction and we add all the voltages that we face with together, it's gonna be equal to 0. So the sum of all the voltages in one mesh must be equal to 0. So in mesh 1, we're gonna start from this point and go in the direction of our I1. So we say we get here, because we are entering from the minus side and exiting from the plus side, it's minus V1. We don't write plus V1. If we were coming from this direction, it would be, because we would be entering from plus side and exiting from the minus one, it would be plus V1. But because we're going in this direction, is minus V1. And then we continue our journey around this mesh. We get to this R1. So we know the voltage here is current multiplied by this resistance. So plus I1 multiplied by R1. Plus here, as we're going, I3 is in the direction of where we're going, so we don't need any minus sign for it. So we say again the voltage here is I3 multiplied by R3, which is, then we come back here, there is no more voltages, so this will be equal to 0. Okay, So to make this easier, we already know what I3 is. I3 is I1 minus I2. So what do? We just put I1 minus I2 instead of I3 in our equation. So we say minus V1 plus I1 R1 plus I1 minus I2 R3 is equal to 0. I'm gonna be adding R3 into this one, so at the end we're gonna get R1 plus R3 I1 minus R3 I2. I'm taking V1 to the other side is equal to V1. Because if you're doing a real example, usually we have numbers and then this is gonna be a number in here, this is gonna be a number. But now we just want to know how this works. So we're done with mesh 1. We're gonna go through mesh 2 and we're gonna write the KVL rule around that. So where do we start? We can start from here and we're going to the according to the direction that we defined for that the current we said this this mesh has. We're coming from here, we get to R3. Okay, the current here is I3, but I3 is not in the direction that we're going. We want this current, we don't want this current. So as we know, if this current is I3, this current is minus I3. So if we add a minus to a current, only the direction will change, the number will not change. So we say minus I3 R3, this is the current in here, the current multiplied by the resistance. Then we come here, we find this resistance and its current, it's I2, so it's plus I2 R2. Here you see we have a voltage source. We are entering from the plus side and exiting from the minus side, so this we'll write it as V2 and not minus V2. Like here we wrote minus V1 because we were entering from the minus side, but here we are entering from the plus side, so it's plus 2. So we are coming back to the point we started. So we wrote all the voltages in this mesh and we say, okay, these all are gonna be equal to 0. Again, we're gonna write I1 minus I2 instead of I3 in here. So it's gonna be minus I1 minus I2 R3 plus I2 R2 plus V2 is equal to 0. You can notice something in here. As you can see, when we are in this mesh, we say our I3, which is in the same direction, is I1, the current for this mesh, minus I2, the current for the other mesh. And as we are here, as you can see, we wrote I3 and then we said it's because the direction is opposite, we say minus I3. So at the end, if we multiply this minus inside this, it's gonna be I2, the current of this mesh, minus I1, the current of the other mesh. So what we learn in here is that if we want to make it more simple and make it faster, especially in our exam to write it down, when we're going through one mesh and we get to a branch when it's both there are two different currents going and coming out of it, we say that the current in that mesh, the current in that branch, sorry, is the current of our mesh minus the current of the other mesh. So here it's gonna be this one. When we come here, we're gonna say I1 minus I2 multiplied by R3. But if we are in the other mesh and we are writing KVL for this mesh, when we get here, we say the current here is our current, which is I2 minus I1, which is the other current. So it's after I solve some example, you're gonna understand better. Let's just deal with this equation for now. Minus I1 R3 plus R2 plus R3 I2. I'm gonna take V again to the other side is equal to minus V2. So we have one equation and we have second equation, and according to this equation we can find I1 and I2. If we are in a question when we have all our resistances and we have our voltage sources, we know the number for everything. The only variables that we don't know are I1 and I2, and we have two equations from these two different meshes for them that we can uh, find out their numbers. Follow me through my next video so you can see more examples. I'm gonna solve some examples and some more complicated examples so you can understand mesh analysis better.